we're going to follow on from last week, where the session at the end of last week was looking at daylight simulation and visualization, and we're going to continue that this week. And then in the second session, we're going to move on to integrated shading design analysis. And as I kind of mentioned last week, the reason that we're spending so much time on daylighting is because it's an area where architectural designers are really in control of that aspect of the building. And I think particularly for those of you who are taking design projects in university now, daylighting design is a really key part of your design strategy and your kind of design agenda. Okay, so we're really spending quite a bit of time on it. You have to excuse my voice, I've got a bit of a cold. The other thing about the reason we're spending so much time on the daylight visualization is because I think the tools that we're using are very, very strong tools, very powerful tools. These tools have really advanced in the last 2 years. So that the sort of sophistication of simulation that you can now do yourself and the speed is really quite amazing. Compared with last week, we were looking at the wind simulation, which, you know, I was quite honest with you, it's not the best piece of software. It gives you a sort of feel for what the wind's doing, but it's certainly not a kind of high-level, sophisticated piece of software. But the daylight simulation really is kind of high-level stuff. Okay, the software and the tools that you're now able to use, 5 years ago they didn't exist. 3 years ago they probably existed, but they were only used by the engineers. They would have been seen as far too sophisticated for the kind of designers to use. Okay, we've then got a third session today, which is a workshop, and what we'll do in that session is we'll see how we have progressed with the other aspects, because there's quite a lot to cover this morning, so I suspect we may spill over into that session a little bit. Okay, and we'll also we'll look at a few of the aspects about how you start to bring together your site models and the building model which I've issued, and some of those issues that are coming out of that. Now, one thing that we're doing this year, the tools have moved on in Revit slightly. So last year we were using 3D Studio Max for daylight simulation on a building scale. Now this year we don't need to, because we can do that in Revit. So what I'm going to do is the 3D Studio Max session, that will be offered on Mole as a video, and you can watch that, but I'm not going to run that in the lecture. Okay, and I'll leave that as optional for you. I think I've said before, but last year a lot of the class just found, you know, they had enough to sort of understand using Revit to then bring in 3D Studio Max. A lot of them just found it too much to take on board. So it's not essential, but I'll offer it out there for those of you who are interested, who want to learn some of the daylighting skills in 3D Studio Max. Okay, right. So we'll go straight into Revit, and what we have here is our site model, and if I just maximize that window, there's our site. We've got a few basic buildings modeled, not all of the buildings, and we've got our design model here. And what we're going to look at in the first session is how we can start to simulate the daylight for a whole building. Okay, if I just go back. Okay, what we looked at last week were these two kinds of simulations, where we were looking at a three-dimensional view, putting a camera into the model, and in the top image, getting a kind of fairly high quality visualization, perhaps moving the sun about, using different times of the day, and then the bottom image, where we were able to actually then look at a much more quantitative daylight factor analysis using a three-dimensional view. Okay, and that's very, very powerful, very, very good piece of software. That very good tool. Now, what I want to move on today is looking at the building on a floor-by-floor level. If I just zoom in on that, so rather than having to look at the building kind of room by room in 3D, how to have a much quicker or a way of visualizing and simulating the entire building in Revit. Okay, and we can do that for illumination, and we can do that for daylight factor. This is a daylight factor simulation. Okay, so what we're looking at here is level 11, which is actually the ground floor in this building, but we called it 11 because of the different heights of the site. And we've got the cafe space here, entrance foyer, seminar room, and some toilets and stairs. And what we're able to do is look at a daylight factor simulation for the whole floor immediately. Okay? So that's what we're going to look at first, how we do that, and then how we perhaps play with that graphically a little bit to make the sort of graphical output slightly more usable. What we'll also look at is how to then do a similar process, but where we are then able to get a more kind of visualization view of that floor in the building, which is what the lower image is, where you get a sort of feel for the quality of light on those floor surfaces. Okay. Right. So, first thing I want to show you, I just go into my render library. Let's refresh that a moment. Okay, so here is a rendered view in Revit, and what we've done here is we've used the section box to bring down the view of the model so that the view is now slicing through the building. Okay, and you get this very nice, it's a very nice image. Fine, great for using that for project work, for visualizing the project. People can see inside, they can see the furniture. Great. See, you've even got a little table football there. Great. But it does not give an accurate daylight visualization, because what it's doing is it's projecting the daylight as if that building's been chopped in two. So if we look into this room, we are getting absolutely flooded with daylight from above because we've chopped the top of the building off. Okay? So, fine to use that image to explain your building, not fine to use that image in terms of daylight simulation. And if you look at the corresponding daylight factor, which I ran for the same view, just look at the key, 100% daylight factor is yellow, then unsurprisingly, the tops of these tables are getting a 100% daylight factor because we've chopped the top of the building off, so effectively they're outside. Okay, so don't make that mistake. I did have a student once who they used this approach. They chopped the top of the building off, and they were so impressed at how good their daylight was. Okay, but unfortunately, their building didn't have a roof on it. Okay, so just be wary of that. But having said that, don't use it for this. Certainly do not use it for this, for a daylight factor. But if you want to use it for this, that's fine. And I think a lot of clients, a lot of tutors would find that a very good way of explaining a building. And of course, as we've shown last week, because we're doing this in the cloud, in Revit, really, really quick. Okay? I mean, all I've done on this is hit render. I've not played with any of the settings, any of the materials. I've just hit render on it. Okay. So, we've identified that that approach is no good for daylight simulation. So let's look at a different approach. Now, if I open a floor plan in Revit, floor plan here. Okay, so there's a floor plan in Revit, but Revit is doing the same. When you show a floor plan and you put the shadows on, because you're telling that floor plan where to crop the view, it's doing exactly the same with what we just saw. It's chopping the top of the building off, and it's casting shadows as if the top of the building has been removed. So, again, fine to use that as a means of just communicating your project, not fine for daylight simulation. Okay, so that's no good either. What we have to do is we have to use the camera in Revit. And we have to generate a view using the camera, because we can put the camera within the building. Okay? And the camera does not then chop the top of the building off. So that's the process that we'll use. There's just a few little excuse me, there's just a few little fiddly settings with it, where it's quite easy just to make a little mistake and it doesn't work. But as long as you follow the procedures, it's actually fairly straightforward. So, first of all, let's just get familiar with our building again. This is the ground floor. If I double click on that section there, ZE, zoom extents, there's our section through the building. Okay, three-story building, lots and lots of glazing on the ground floor. Let's go back to our floor plan. Okay, we've got the big cafe space, the entrance area, and the foyer. Okay, now you might notice, I'll just zoom in there, there's some shading here which is not appearing on the section. That's because I've got a view option shown. I'm just going to change that because we're going to cover that later. VV, and if we go into our design options here, at the moment we're viewing our option 1B. So we'll just change that back to our automatic, which will show the base model. Okay, so those shading devices are now disappeared. In the next session, what we're going to do is, when we look at shading design, we're going to start adding some shading devices in design options, and start to look at the sort of way of using those design options to test the design. But for now, we'll just keep it simple. There's our building. If I just go into the 3D view, WT is Windows tile. And I'll just maximize our 3D view. Zoom in a bit. Zoom in again. So there's our building, and at the moment we're looking at the ground floor. So it's got all this glazing, and we've got a little bit of shading here. Okay, just to show you, at the moment we are simulating this version of the design where all of that glazing is unshaded. Okay, but if we VV, just to show you what we will be testing, if we then change that to some of the design options that I've already created, then later on we'll look at design option 1C, where I've added in all this horizontal shading to try and screen some of the daylight. Okay, but I think for now we'll just keep it with the simple base model. VV, just to switch that off again. Okay. And generally, what I would say is when you are starting to work with daylight, normally the best approach is to start testing with an unshaded design, and then start bringing in the shading and seeing the impact of that shading on the daylight. Okay. If you start with the shading, you might find that it doesn't give you a very helpful start point. Okay, generally start unshaded. Right, let's go back into our plan view, and I'll just switch the shadows off for now because they're not really any use to us. So I was just using this little button down here. What you might notice is I've cropped the view. So if I just go back down here to the bottom, do not crop view, ZE, zoom extents. So there's our view with our buildings in it, and this is our crop box, which you can click and drag. But for our purposes for today, we're only interested in visualizing inside the building. So we're going to crop the view using this. Okay. Crop it down. You can then drag the crop box to the size you want. But the reason I'm doing this is because it will just slow the computer down to continually have all of the buildings shown. Now, the buildings are still being used for shading. We're just simply not viewing them. Okay. And it means now when I hit ZE, zoom extents, it will zoom to our much smaller part of the building. Right, I've got various elevation markers, so I'm going to select that elevation marker out there, right click, hide in view, elements, just to hide that, because I don't need that. And then the other thing that you might want to consider is our detail level. So if you look at that wall build up at the moment, it's showing the construction of the wall. Now that's probably not relevant when you're looking at daylight. So if we change that down to a coarse view, it will change the way we see that wall to just a more basic wall, okay, which is fine for what we're doing today. So there's our ground floor plan. So we need to now go ahead and put the camera in. I'll just save there actually, just in case. Okay. So we go to view. We've put cameras in before, but I'll go through it again. And 3D view, camera. Okay, just give it a second. So you see the little camera is now following my cursor, and for our purposes it actually doesn't really matter where we put it, but I'm just going to click it. Oh, made a mistake there, sorry. This is the thing you have to watch for. Do that again. Camera. Now, before you place it, go up to here where it says perspective. Okay, top left. And deselect perspective. because we don't want this to be a perspectival view of our building. We want it to be an orthographic, just a plan view. So do that before you place the camera. Click and drag and click again. And I'll just there's our camera view. And all we need to do now is go to a plan view by clicking on our view cube over here. Go to top. Okay. Just drag the extents of the window. And we've created a plan view of the building using a camera. Okay. I'm just going to drag the extents of the view so that it's just seeing our building, which again will just make things a bit quicker, a bit clearer. So I've dragged that in. ZE, zoom extents, and I'll just drag that quite close to the building. Now what you might notice is at the moment we are looking down on the roof. So the camera's not in the right place, we're looking down on the roof. Now the thing to do, before you start moving that camera, is we want to lock this view. What will happen if you don't lock this view? We have a camera and we have a destination point for it. So imagine if that there is the destination point, and see that, and there's my camera looking at it. Now if I don't lock it and I start moving that camera about like that, it will continue to look at that point. It will no longer be looking straight down. So by locking the view, it just locks it in that vertical view, so it's always looking down. Okay. And you do that down here. Unlocked 3D view, click on that, save orientation and lock view. Okay. When I was practicing this, I kept forgetting to do that. And every time you move the camera, your view just completely changes. Right, so we've locked that. Now we need to get that camera into the right level. So, as always, to activate the camera, you need to click on the box which is bounding the camera view and go over here into your properties, and if we look over here we have eye elevation and target elevation. Now I happen to know that our wait a minute, I'll just go to the section just to check. If we go back to the section, there's our levels in the building. So level 10 is at 115,000, level 11 is at 118,600. So we want our camera above level 10. So I go back to our camera view. Okay, let's set our eye elevation at 115,850. So we're putting it here in the room, at about desk level in the room. And let's set its target elevation at 115, at the floor level. So it's looking down at the floor. Okay, and you'll see there that our view has changed. So we're no longer looking from above, we're now in the building, but the key thing is this is a camera view, not a plan view. And when I put the shadows on, we now get a shadow pattern which is a realistic shadow pattern within the building. So this is not chopping the top off the building anymore. Okay? And if I put them both up at the same time actually. give it a second. So that's the same view. So on the left we have our camera view, and on the right we have our plan view where we've chopped the top off the building. And you can see that the shadows are completely different. Okay, the one on the left is giving you a realistic shadow pattern, and the one on the right is not. Just save that there. Right. So, using the view on the left, the first thing you could do, the first output, would be to simply use this to give you an idea of sunlight tracking. So sunlight tracking is when we talk about the pattern of the sun moving about within your building. And that's particularly important in rooms where you have work surfaces or for dwellings where you want some sunlight. So what we could do is we could simply export this image as it is, or if we go back into our sun settings and using some of the techniques that we looked at before, if we go now, for example, to a single day, and let's do a spring equinox solar study, and let's have this from 9 o'clock in the morning through to 5 o'clock in the evening. Okay, we'll have it at 1 hour intervals, and we don't need to see that ground plane. Okay, so we've now set the sun settings to visualize this shadow pattern throughout the day. And we have covered this before, but I'll just do it again. If we then go to export, excuse me, images and animations, solar study, it will bring us up to the option box here. Just checking. Let's just put that on shaded with edges. You can change the size, the pixel width. You can include the date and timestamp, which is normally quite helpful. Okay. And then it takes us into this dialog box, and you might remember we've been here before. It offers you AVI files, so it will offer you a movie file, but to be honest I find that not really very helpful. I normally find it better just to export JPEGs. Let's just put it somewhere logical. I think it was March. Can't remember what date I set now, but it doesn't matter. Okay, so we tell it to put the images in that folder. Hit save. It will now start to export those images. You see it going through. Okay. And if I just find that location, so we have the that single day study of the shadow pattern. Okay, it's not giving you a sort of sophisticated render quality. It's purely giving you a tracking of the sun within your building. Okay, but that's very useful, very quick. Okay, really, a really good tool to use actually. And you just see actually when you see the impact of the shading that we have got here on the shadow pattern. Okay? And obviously you can play around with the settings. I mean, I've set that, it's far too dim. Yeah?
Are there adjacent buildings affecting the simulation?
Yes. But I've got a feel, yes, they are. But I noticed when I opened that model, I've got quite a few buildings missing.
Okay.
Yeah. Yeah. Good point. But yes, they will. They will be casting shadows. Okay, so that gives us a very quick way of looking at the sun path, okay? But now we want to move into a more sophisticated daylight factor analysis. So, we go back to our 3D view, and I'm just going to change those sun settings back to a still. Okay, rather than doing a multi-day, I'm just going to change it to a still. Let's just put it on the equinox. Let's put it at 9 o'clock in the morning. Okay. And what we're now going to do is use the cloud rendering service to render this view. Just hit save before we do that. Okay. So as before, we go to view, view up here, render in the cloud. Okay. I'm just going to come back and change something. I didn't give my view a meaningful name. So it's called 3D View 8, which doesn't mean anything. So before I send it rendering, I just want to give that a more meaningful name. Okay. So I'm just going to go to the view here, right click, rename, and let's call this level 10 option A daylight factor analysis. Okay. Otherwise, if you don't give it a meaningful name, all of your renders just have all these odd names. You don't know what on earth they are. Okay, so I've done that. Now let's go back to render in the cloud and select the view. Normally it would select the view that you're in. Let's just find it. This was our, don't want that. So we've selected the correct view. Okay. Output type, we want illuminance. The size depends on how much time you've got. I'll put it on just large for now, but I mean, you know, if you've got plenty of time, you can put it on maximum. It doesn't matter. Sky model, we want to use the daylight factor sky for this simulation. And in the legend, what I'm going to do is I'm going to start off using the legend. This is the key, and we'll start off from 0 to 20%. Okay, because based on, we've got a lot of glazing in this room, so we want to have that range of scales. Now, later on, once we start putting some shading in, we'll probably start using 0 to 10%, because we're not going to be getting 20% daylight factors. But for now, we leave it at 20. Okay, it's telling you that it will need 2 credits. Fine. Start rendering. Okay. So it's packaging that up. Oh. Okay. Let's just try that again. Okay, an authentication error occurred. And I think what is going on is I sent quite a lot rendering this morning. I don't know if it's blocking me out, but anyway, it doesn't matter because I've got them all pre-rendered. I'm not quite sure why it's doing that. I don't have time to log out, log back in again. That's probably the answer. But let's just look at the ones that I pre-rendered yesterday anyway. Okay, so this is the output that you will get. Oh, that's set to 10%. Okay, so that's the one that I rendered before. Okay, so that's what you should get out. So what you can see we're getting is we're getting a floor plan rendering of the building using daylight factor. And I was mentioning the scale from 0 to 20. Now bearing in mind we've got huge amounts of unshaded glazing, then unsurprisingly we're getting these very high daylight factors. Okay, and then as we move deeper into the building, we move into the reds, which is 14%, the greens, which is 8%, and the blues, which is sort of 0 to 2%. So what you can see from that is you're getting some very high levels of daylight, but we're not getting very good uniformity. So it goes from quite dark at the back to very, very bright at the front. And so that's already starting to tell you something about the quality of the daylight. If we look at our toilets at the back, which have no windows, we have a 0% daylight factor, unsurprisingly. And if we look at this room here, we're getting very sort of very bright light close to the windows, and then much darker inside. And if you remember on the model, this window is already shaded. Okay? Now, if I go back to my 10%, okay, so you see the difference now. This is now doing the same visualization, but this time I'm using the scale from 0 to 10%. And because we're using a different scale, it gives us a bit more information, certainly for this room, where you can now start to realize that these greens are in the sort of 3 to 4%, and the green here is in 3 to 4%. So you're getting a much more detailed level of information because you're using a finer scale. Okay, now those images as they are perfectly okay for simulation, for analysis. And at this point, I would suggest you have a choice. You could take that JPEG and start to use it in a report, or start to lay it out on a sheet, start to insert it into an image as it is. Okay? And you might then, if you took that into InDesign, you might start to annotate it with room names. You might start to put some arrows sort of indicating your analysis of that. And that's perfectly good. Now, what you notice about the image is it doesn't have the sort of detail line work of the Revit file. If I go back into Revit and open the sheet that I was showing you before, what you might want is a view rather more like this, which has the simulation, but it also has the detail of the model. Okay? Now, I'll go through that in the next session, how you can start to combine those two images to make that kind of graphic. But I think it's important just to realize that the information is here. Okay? Everything else we're doing is just a sort of graphic device to make it more easy to read. But certainly for speed, this is perfectly acceptable. And this is obviously one floor of the building. You could then repeat the process for the other floors, and you have a whole building simulation. Okay, what we're going to do is go back into Revit, and just to show you now, to produce this kind of view, where we're getting a more kind of rendered image of the ground plane, the floor plane, you've got two options. Go back into our cloud gallery. You could select one of these renderings that you already have without opening Revit, and you could re-render using new settings. So I'll try that. I suspect it's going to say that I'll probably get that same error report as before. Okay, so it will allow you now to do a visualization render. So it needs to know the time of the day, time of the year. So I'll just leave that on 22nd of September. Let's put it at 10 o'clock in the morning. Okay. And sorry, I didn't know that. Sorry, I'm getting that confused. We can re-render this now to do an illuminance. Okay, so the rendering we did originally was a daylight factor. We can now change this to, for example, a clear sky. Oops. And we can change the size of it. We don't want it in foot candles, we want it in lux. Let's just change that to automatic for the scale. So we can now re-render that view not as a daylight factor, but as an illuminance render for a particular moment in time. Okay? And the really great thing about that is the speed of it. So I can now do that again. Let's change it to the afternoon. 15. Clear sky. Okay. Automatic. Start rendering. So we've set those both rendering. So we've now, in 60 seconds, we sent two different illuminance renders as well. Really, really rapid. Okay. So they're busy working away in the cloud. Go back into Revit. And I'm sure this is not going to work, but I'll go through the process anyway. And in the break, I'll have to go and log out and log back in again. So let's go back to our 3D view for daylight analysis. And again, render in the cloud. Okay, and this time we are going to do a still image. Because we don't want an illuminance, we just want a sort of visualization. So we do a still image, render quality, final, image size, large, let's say. File format, PNG is okay. And I'll hit start rendering. I suspect it will not work. Don't know why that's happening, but yeah. Okay. So I suspect I just need to log out. Not quite sure, but anyway, that would send it off to the cloud, and this is the kind of result you would get. Okay. If I just download that, so you get, I mean, this was a, I think a sort of large size, but you get quite a decent, quite a reasonable rendering of the ground floor. This doesn't have any furniture in. I mean, this doesn't really have any floor surfaces in either, but imagine if you had floor surfaces. that can give you a good underlay if you want to start using that for your design drawings, or if you want to use that in a report, just to give a slightly better sort of feel of the quality of a space. Go back into Revit, and then what we'll look at when we come back after the break is how you could then start to assemble these into a sheet. So what I've done here is I've just quickly started a sheet in Revit where we want to have the daylight factor render, we want the sort of simulation render, we want some interior views, all on the same sheet. Okay, and you can use Revit to start to assemble those views onto a sheet. Obviously, you could do the same thing in Illustrator, InDesign, Photoshop. But the important thing to bear in mind is, in a practice environment, the way Revit is normally run is it's the single point of information. So all of your project drawings will be in this one file in Revit. So any of the design team members can have a look and they can see the work, they can see the sheets. Now, if you start laying out sheets in a practice context and you start doing that in InDesign, then people will not know that they exist. Whereas this project only has 2 sheets at the moment, but if you look here, down here, these are all of the drawings in this project. Now on the project that I was working on recently, we probably had about 1,000 drawings of the project, including all the structural drawings, and they were all here. So every drawing you can access through the Revit interface, rather than having drawings sort of all over the place in different formats. Now, for you as students, it's up to you. You may prefer, for the purposes of this report, you might prefer just to use InDesign rather than having Revit sheets. But certainly when you get into your design projects, I would encourage you to consider using Revit to lay out sheets. And just before we finish, zoom in here. The thing to bear in mind is Revit is completely customizable. So this is the standard Revit sheet name, graphic, which most people use by default, but of course you can change that to anything you want. So if you are laying out images in Revit, you are completely in control of the graphics of how it looks.